Okay, so we should be about right here on our notes. And I'm going to make these really large so we can talk about them. So today we're talking about domain and range, and we're writing the domain and the range using inequalities if we can. We're going to write it using inequalities if we can. So remember, for the domain, we started off as D domain is a set of all x's such that. So talk to me about the x values. What is the smallest x value? What is the largest x value? So if I look at this graph, it looks like this is my smallest x value, and it looks like my largest x value, I think that's going to go on forever. That's why there are arrows at the end of it. So how can we identify the domain using an inequality? What do we know about the x values? They're what? What's the smallest x value? -2. So the domain is all x such that x is greater than or equal to -2. So that means -2 is included, but it's also talking about every number that's bigger than -2. Let's talk about the range. So the range is the y values such that, so let's see. It looks like my y value, if I go on forever, how high up is that going to go? Remember, this graph goes on forever. What's the tallest y that it's going to reach? Any ideas? If the graph is going to go on forever, what's the tallest y value it will reach? That's where that's where the arrows are, but it keeps going. These arrows mean that it keeps going. Okay. So this graph right here, like if we look at it right here, it looks like -2.25 or -2.3 and a +2.3, but these go on forever. It's going to keep going forever. So what's the highest x value? Like positive infinity, right? It's going to go on forever. So the way that we identify the range is we say that the range is y such that y is all real. So real numbers, you can abbreviate it as a capital R. I'll write it out. You can abbreviate it with a capital R if you put a double slash through that, like this. This is real. All real numbers. That's how we do that. So the range is all real numbers. Okay, I know this is a new concept. Let's look at the next graph. Okay, so let's talk about the domain, which is all my x values. So these are x values going this way. If this graph goes on forever, what's the largest x value? And if it goes on forever this way, what's the smallest x value? So what can we say about the domain? Good job, Cheyenne. It's all real numbers. X is all real numbers. Okay, now let's look at the range. Those are our y values. So we're going to look at the verticals. So let's see. This is the lowest point on the y-axis. Like this is the lowest vertical point right here. And if I look at the y-axis, what is that point? That's the lowest it goes. What is this point? It's -1 on the y. So y such that y is greater than or equal to -1, because it's taller than that. It's bigger than that, right? If the graph had gone in a downwards, so like if this graph wasn't going upwards, but instead it was going down like this, we would say y is less than or equal to -1. Okay, this is an absolute value graph. This is an absolute value graph. All right. Let's look at this last one. This last one is a little interesting. We got a couple of things taking place there. So let's look at our domain first. Remember, domain is the x values. So how far is this going to go this way, and how far is it going to go that way? Those are my x values. X such that x what do you think, Miles? It is. X is all real numbers. Now let's look at the range. So we need to look at, even if this graph goes on forever, what is the smallest y value and what is the highest y value? So what's the smallest y value? -1. So y such that -1 is less than or equal to, I'm going to write a compound inequality, y, which is also less than or equal to, what's the highest y value? +1. So if I had not smashed it together like this, I would say that y is greater than or equal to -1 and y is less than or equal to +1. And I said and remember, when you have an and, you take the smallest numbered inequality and you rewrite it so the small number comes first. So I'm going to put the -1 first and flip the sign and then smash the other inequality into it. And that's exactly what we did down at the bottom, okay? You're combining your and inequality and making it compound, writing it as one compound inequality. So that's domain and range. Now let's do some evaluating of functions. So the function right here, this is the function f of x in the graph. It's not a linear function because it's not one straight line. It's called a piecewise linear function because it's straight lines, but they're in chunks or pieces. That's why it's called piecewise, okay? So this is a piecewise because it's a bunch of little straight lines in pieces hooked together. So when I want to look at this graph and I want to see what's happening at f of 1, that means this is the same thing as saying let x equal 1, right? So if I go to my graph and I look at when x equals 1, what is my value of y? What do you think, Macy? When x is 1, this is 1 on the x-axis, what's the value of y? How high up did it go? What point is that? Yep. Yeah, so when x is 1, f of 1 is 4. Let's look at what happens when, I'm going to write one in. Let's look at what happens when f is -2. So at f of -2. So go to -2, which is back 1, 2, and go down to where the line crosses. When I let x equal -2, what's my y value or f of -2? What's that? -2. Okay. This is saying what happens when x is 5. So let's see, I'm going to go over 1, 2, 3, 4, 5. And when x is 5, it crosses, like the y hits right here, which is what? -2. What about when I let x equal -3? So I'm going to go back 1, 2, -3. And I find out that it's what? -4. What about when I input a 0? When I let x equal 0? F of 0, the output is what? 2. Does that make sense? You're just replacing the number inside of the parenthesis. So this is what it's saying. Let x equal 5, 0, whatever. F of x is your output. So f of 5, the output. This says, dang it. This says when x equals 5, the output is -2. That's what this says in terms of like thinking about it. When x equals 5, the output is -2. Are you guys good with that? Okay. So now we're still going to look at the graph, but we're going to figure out what the input is. We're going to figure out what x is given the output. Okay. So here we have to find x that produces the output f of x. So where is there an output of 0? Meaning, when does y equal 0? So let's just go touch the graph, highlight all the points where y equals 0. Well, y is 0 right here. Y is 0 right here. Are there any other places on the graph where y is 0? Yes, where is it? Right here, correct? Okay, so now we need to figure out what those x values are. So let's see. Y equals 0 when I let x equal what? -1. Y equals 0 when x is what? 4. And y equals 0 when x is 7. Does that make sense how we did that? Because it's kind of backwards from what we've been doing. It's kind of backwards. So I had to look at my graph up here and determine what the output was. So I highlighted all the zeros on the y-axis and then figured out what those inputs were. Okay? So we're working backwards. So what about if I look at all of the outputs of 2? So let's find all the places where y is 2. So it might be easier if you just draw a line across the y equals 2. This is where y equals 2. This is the line y equals 2. So draw your line and then touch the point where the line intersects the graph. So there are 2 spots where y equals 2. Does everybody see that? What are those 2 spots? What's one of them? Staley, what's one spot? What's one x value where y equals 2? So when x equals 2, 3, yeah, good job. X equals 3. So at f of 3, my output is 2. Perfect. And what's the other one? There's one more. Yeah, good job. At f of 0. Awesome, Alexis. So those would be your 2 values. You could write it as x equals 0 or f of 0 equals 2, f of 3 equals 2. Questions? Okay. What is the largest output achieved by the function? And at what x value is it hit? So let's look at this graph and we're going to find the largest X or the largest output, meaning what's the highest this graph goes on the X-axis or on the Y-axis. So the highest this graph goes is right here. This is our output. And what is that? 4. Good job. What X value or what input is that achieved at? What's this point? This happens when X is what? 1. So the largest output happens when f of x is 4, and it really happens at f of 1 equals 4 is the largest. Nothing goes higher than 4 on the y-axis. If I ask for the lowest, what is the lowest or the smallest output? What's the smallest output? What's this number right here? -4. And that happens at what? So f of -3 equals -4. And that's your lowest or your smallest. Okay. I know that wasn't one of the questions. I just want to make sure you understand. Okay. Let's see what Sarah's doing. So Sarah's car holds a maximum of 12 gallons of gas. The function f of g, where the output is a function of the gas, 3.5 G models the relationship between the cost of gas and the number of gallons purchased. So what is the most appropriate domain? So we're just thinking about the input values. Remember, the domain is input values, and this is your domain, and this represents gallons of gas purchased. So let's see, the domain X such that, think about it. Can you purchase 0 gallons of gas? Yeah, you can. Can you purchase 5 gallons of gas? Can you purchase 5.5 gallons of gas? 5.25 gallons of gas? Can you purchase -7 gallons of gas? No. So what do we know about X? It has to be what? Positive or 0. So X has to be greater than or equal to 0. If you don't purchase any gas, you don't pay any money. But if you purchase -1 gallons of gas, you don't get $3.50 back. That'd be great, right? Go to Speedway. Hey, I want -10 gallons of gas. Please pay me $50.75 or whatever, right? Like, it doesn't work like that. It'd be great if it did, but it doesn't. What's the most appropriate range? So now we're thinking about the Y values. Is it going to be all real numbers? If I purchase 0 gallons of gas, the output or the range is going to be $0. If I purchase 100 gallons of gas, the output is going to be $350. What can you tell me about the range? Same concept as the domain. What do we know? Can't be what? Say that again. Yeah, it can't be less than 0. It's got to be positive. So let's say that Y is such that Y is greater than or equal to 0, right? We can't have, in real world examples, you can't purchase or create negative things. So typically you have to watch that for your domain and range. Like if I'm setting up a candy shop, I can't use numbers on my graph for negative amounts of candy, right? Example number 10. A rental company uses the function f of x equals 150x plus 75 to calculate the cost to rent a beach house for X number of nights. So this is the number of nights. So looking at this equation, what does it cost for one night at the beach house? Or what is the charge? Don't even answer that. What's the charge per night? What's the per night charge? 150. It's the number attached to the X. So this means that I'm paying 150 per night plus that $75, probably just rental fee. Like that's my one-time fee for each booking, right? That's my one-time booking fee. So we're going to choose, it says that the maximum number of nights is 30. The maximum number is 30, meaning that X cannot be bigger than 30. X has to be less than or equal to 30. What's the minimum number of nights? Zero, but would you rent it for 0 nights? So what do you think it is? What number is it? What example choice do you want to choose, A or B? A. What is this number representing right here? Can someone tell me? That's not my domain. What is that? That's my range. Yeah, they're trying to trick you. This is a range value. Okay, last one. We're going to find the domain, the range, and then we're going to determine if this is discrete or continuous. So the domain, remember all X values, the domain of this function. I'll write the function. Do you guys want me to tell you what the equation for this function is? Would that help you think about it? Yes or no? Some of you are saying yes. The function is x squared plus y squared equals 4. That's that. If you were to graph that on your graphing calculator, that's what you would get. So what's the domain? Meaning, what are the X values? Well, X doesn't go any farther between these two places. What is that? Yeah, -2 and 2. So we're going to write it like -2 less than or equal to X less than or equal to 2. That's our compound inequality to represent the domain. What about the range? It doesn't go any higher than this, and it doesn't go any smaller than this. What's our range? I forgot to sneak that little X in there. Y such that Y, what? What are we saying about our range? What's the highest it goes? Same thing, right? -2 less than or equal to Y less than or equal to +2. They have the same set of points. Same set of points. So that's our domain and our range. Is this a function? I heard someone say no. Why? Does not pass the vertical line test. No. Does not pass VLT. Is this function discrete or continuous? Continuous. Good job. Remember, continuous is just that. It's a line, it's a curve, it's whatever. Discrete is this. Discrete is a bunch of points. This is not a bunch of points. Discrete's not connected by lines or curves. This is a circle. This is the equation to a circle. It's written like this. X plus, well, this is really the equation. Do you guys take geometry here? Like is that math 2? Is math 2 geometry? Does anybody know? No? Okay. You'll learn equation. I'll make sure that we do something with the equation of a circle. Okay. Flip it over. We're almost done. We have one more example. So example 12. It's so funny that we have an epidemic of influenza spreading through a city. So you have an epidemic of influenza. The figure below is the graph of I equals F of W, where I is the number of individuals in the thousands affected in weeks after the epidemic begins. So this is your number of weeks, and this is the number of people in the thousands. So this is people in the thousands. So estimate F of 2 and explain its meaning. So F of 2 right here, that means I let W equal 2, and the output is about right there. So I would say that F of 2 is about what? It's about 7. Yeah. And it means that in the second week of the epidemic, 7,000 people were infected. Approximately how many people were affected at the height of the epidemic? Meaning the height is when the most amount, like when it like reached its peak, right? The height is where it reached its peak. It maxed out. So how many people do you think were infected then? And let's write our answer in a function form. So the height is where? Where's the most amount of people being infected? It's approximately at what? It's a little bit above the 8. 8,500. When did that happen, Isaiah? When did that happen? After how many weeks?
4.
Yeah, so F of 4 equals 8,500. And I'm actually going to write it as 8.5 because we just need to know what it means. So we know that about 8,500 people were infected in the 4th week. F of 4 is 8.5. Okay. When was it that your output, this is saying, when was your output about 4.5? So when did that happen? Week what?
4.
It could be at week 1. F of 1. And what's the other one? F of 10. So what does this mean? This means in the 1st and 10th weeks, about 4,500 people were infected. Do you see how drawing a line through like kind of tells you where to match it up on the graph? Is that helpful for you to figure out if you can find your output lines to kind of draw down where your inputs are? Maybe yes, maybe no. An equation for the function used to plot the image above was F of W equals 6W times 1.3 to the negative W power. Use the graph to estimate the solution to the inequality 6W times 1.3 to the negative W when it's greater than 6. So here's what this is saying. It's saying that this is the function used. Our output is greater than 6. So when was it that our output was greater than 6? Let's start with that. When was our output on this graph greater than 6? So between weeks, I would say between like weeks 1 and 8, right? Greater than 1, less than 8. So we're writing an inequality. So W is less than 6, but W has to be greater than 1. So 1 is less than W is less than 6. So what does it mean in terms of the epidemic? It means that what? Between weeks 1 through 6, more than 6,000 people were infected. Notice that I didn't use like 1 is less than or equal to W is less than or equal to 6, because at week 1 it's like 4,500, but it's right after that it goes up, right? Okay. So our homework for today, you have 2 things. You have pages 16, 17, and 18, which is really 4, 9, 10, 11, 12, 13, 14, 15 questions. But what else is due tomorrow? Your Desmos. Do you want me to do one of them with you, one of those together? Do we want to do one of those graphs together? Your homework are pages 16 through 18. And remember, you have your graphing stories, and you need to choose